Why does the chicken on a plane taste like cardboard while the same dish on the ground can be rich and alive? You might blame the chef, but the real culprit is the sky itself. The cabin, the air, and your own body playing tricks. In this video, we'll follow a bite of food from tray table to tongue and reveal the surprising chain of physics, chemistry, and neurobiology that changes flavor at altitude. By the end, you'll know why airlines use extra salt, why spicy sauces feel essential, and what simple hacks you can use to actually enjoy your in-flight meal. Let's start with the obvious. Most of what we call taste is actually smell. Flavor, the thing you think of when you chew, is mostly retronasal olfaction. Volatile molecules rise from food into the back of the throat and nose and activate the olfactory receptors. Those receptors provide the rich, complex notes that transform bread into fresh-baked buttered loaf, or tomato into roasted sun sweetness. Without aroma, flavors flatten fast. The airplane cabin attacks that system from two angles. First, the air is dry. Modern cabins often have relative humidity around 10–20%. That dryness dries out your nasal mucosa. Your mucus layer is not just gross biology. It is the medium in which odor molecules dissolve and meet receptors. A dry nose gives you fewer olfactory signals. Second, cabin pressure is lower than at sea level. Commercial jets cruise with a cabin altitude equivalent of roughly 6,000 to 8,000 feet. That lower pressure changes how volatile molecules evaporate from food, and it directly affects your taste receptors. At reduced pressure, some aroma molecules partition differently between food and air, so fewer of the ones your brain needs for nuance are available retronasally. Meanwhile, your taste buds themselves become less sensitive to certain tastes as pressure drops. That's why sweet and salty notes, which are heavily receptor-driven at the tongue, tend to be muted in flight. Put these two effects together, and the bite you expect to burst with flavor becomes dull and anonymous. But there's another layer, sound. Aircraft cabins are noisy places. The constant drone of engines and airflow creates loud, broadband noise. Perception scientists have shown that ambient sound changes how we perceive flavor. Long, low-frequency noise tends to suppress sweetness and enhance bitterness and umami-like sensations. In practical terms, that means the hum of the cabin steals part of the sugar perception that makes desserts taste dreamy while lending an odd savory edge to other foods. The brain does this because perception is multisensory. Auditory input influences what we taste. Imagine sound as a seasoning. Now add in food science realities. Airline meals are not cooked mid-flight. Most dishes are cooked on the ground, chilled or frozen, transported, and then gently reheated in the galley ovens. That reheating process cannot reproduce the high-heat, fresh cooking chemistry that creates complex roasted flavors. The Maillard reaction, the chemical browning that produces caramelized toasty notes, requires high, dry heat and time. Reheating in a moist environment suppresses those reactions. Also, the water content of many reheated dishes changes. Texture matters for flavor release. A soggy crust does not deliver the same volatiles as a crisp one. Packaging and transport further sculpt the chemistry. Seals trap or strip volatile compounds differently, and tiny oxidative changes during storage alter the aroma bouquet. The result is food that is both compositionally and perceptually different before it ever reaches your mouth. Now put the passenger into this altered environment and you start to see the whole network of causes. Dehydration is common on flights. Low humidity plus mild dehydration reduces salivation. That is important because saliva helps dissolve and transport tastans to receptors. Less saliva equals less efficient flavor extraction. Add mild hypoxia, a little less oxygen in the blood at cabin pressure, and cognitive sharpness and sensory thresholds shift slightly. Your brain is less able to assemble sensory signals into a rich hedonic experience. Altogether, the cabin environment flattens the raw input and the brain lowers some of its gains. Airlines know this. That's why airline R&D teams and catering departments do two predictable things. 1. They boost seasonings. Salt and sugar are increased because those tastes survive better at altitude. Salt enhances savory perception and triggers appetite. Sugar provides a baseline sweetness that helps keep desserts pleasurable. 2. They bias dishes toward acidic, umami, or spicy profiles. Acidity cuts through dullness. Umami, the savory taste associated with glutamates, remains robust in the air. Spices provide trigeminal stimulation. Capsaicin, menthol, and ginger activate chemical sensing nerves in the mouth and nose that aren't purely olfactory or gustatory. Those sensations feel vivid even when aroma is muted. That is why a Bloody Mary, a spiced curry, or a citrus-forward salad can succeed where a delicate cream sauce fails. There are practical corollaries too. Wine tasting at altitude is notoriously different. Many sommeliers find that tannins and acidity behave oddly, and that delicate aromatics get lost. Some airlines adjust beverage service accordingly, offering red wines with higher fruit concentrations or recommending bubbles that provide additional tang. So what can you do as a passenger to tilt the odds toward pleasure? First, hydrate. Drink water before and during the meal. Good hydration keeps nasal mucus healthy and saliva flowing. Second, choose bold flavors. If the menu offers a spicy or acidic option, take it. Those elements survive the cabin gauntlet better than subtle, creamy dishes. Third, use condiments. A squeeze of lemon, an extra packet of ketchup, or a dash of hot sauce immediately increases volatile release and provides strong trigeminal cues. Fourth, reduce noise where possible. Use noise-canceling headphones or lowering cabin noise with earplugs can improve sweetness and aroma perception. Even moderate reductions in background sound change flavor judgments. Fifth, warm food helps. If you can request something freshly heated or a dish with a crisp element, the textures release more aroma molecules. Bite into warm bread rather than cold. Sixth, carry small aromatic boosters. A tiny sachet of espresso grounds, a lemon peel, or a mint can pump retronasal stimulation and prime your olfactory system. Just a small sniff before you eat can change how the whole tray tastes. Let's zoom into a quick mental experiment to make the mechanism feel concrete. Imagine you have two identical chocolate squares. With your fingers dry and in a quiet room, they taste concentratedly sweet and cocoa-rich. Now imagine the cabin. Dry air, engine roar, and slightly chewy texture after travel. You would likely rate that chocolate as less sweet and less aromatic. Add a splash of water and a short sniff of orange peel and the chocolate pops back. Why? Hydration recovers mucosal function, water helps dissolve flavor molecules, and the orange primes olfactory expectations so your brain completes the chocolatey profile. That priming effect is powerful because perception is predictive. Our expectations and recent smells bias interpretation of ambiguous sensory data. Airlines sometimes exploit this with pre-meal bread service and aromatic trays. The smell of warm bread primes appetitive circuits and boosts the perceived quality of the meal. There are interesting research tangents here. Scientists study how different volatile compounds partition at reduced pressure, how engine noise interacts with taste receptors, and how individual differences in olfactory sensitivity change the in-flight experience. Genetic variation in taste receptors matters too. Some people are super tasters and keep more sensitivity in the air, while others are more prone to the flattening effects. Age is also a factor. Younger people often retain more olfactory acuity. Policy and design implications are obvious. If airlines want happier customers, small changes matter. Humidity control, careful menu design emphasizing umami and acid, improved reheating technology that preserves Maillard compounds, and noise reduction strategies. Some carriers already test taste-optimized menus in flight simulators to tune recipes for cabin conditions. Finally, there is a human side to the story. The fact that a simple environmental shift can alter taste so dramatically is a reminder of how embodied perception is. Flavor is not an absolute property of food. It is an emergent experience built from molecules, air, sound, physiology, and expectation. When you pick the spicy curry at 30,000 feet and it makes you smile in the plastic tray, you are enjoying a victory of design and biology against a harsh environment. To close with the piece of practical advice you can use on your next trip: drink water, choose bold flavors, use condiments, and if you care about wine or dessert, consider saving that tasting for the ground. If you liked this unpacking of a familiar annoyance, hit like, share it with a fellow traveler who wonders why the meal tastes different up there, and subscribe to How It Actually Works for more clear, visual explanations that turn everyday puzzles into tools. We break down the hidden mechanics so you can travel smarter and taste better, one simple insight at a time.